Hi everyone, welcome back. This is week 3 of the problem solving session for the NPTEL course of Bioreactors. I hope I'm audible to everyone. Can you just write yes or no in the chat? Yes, alright, thank you. And I hope the presentation is visible as well, right? Yes, alright, thank you. So without further ado, I would like to start with this week's problem solving session. Alright, so as I do always, let's have a small overview of this week's topic. So in this week's module, you would have learned what are the kinetics of the batch mode of operation, the kinetics of the continuous mode of operation, the kinetics of fed batch mode of operations, and the different cultivation parameters that affect the bioreactor performance like temperature, pH, aeration, agitation, etc. Right? So let's move on to the first question. So the first question is lag phase is and the options are a period which results from nutrient depletion or toxin accumulation, a period with secondary metabolite production, a period in which there is no change in the cell concentration, typically at the beginning of a batch growth, or a period of exponential growth. So what do you think the answer is? C, alright. C. Alright. Does anyone else think that the answer is something apart from C? Alright. I do D. Alright. So, before I move on, I'd just like to remind you that certain questions will have answers more than one, right? Like, not just one correct answer, but more than one. This might not be one of those questions. So, before I move on, I'd just like to remind you what each phases are. So, what you see here is the lag phase. The At the starting of the graph that you see is the lag phase. Then you have an exponential phase, which is also called a log phase, and then a stationary phase. So the correct answer would be C, a period in which there is no change in cell concentration, typically at the beginning of a batch growth. So what happens is as soon as you add your cells to a bioreactor, or a reaction in which nutrients are provided, it takes a little time for it to get accustomed to it before it starts to actually divide, right? So that period is called the lag phase where there's not uh, really any increase in the cell amount of cells, all right? So the correct answer is C, a period in which there is no change in the cell concentration, usually seen at the beginning of a batch growth. Alright. So question number 2 is identify from the below statements which are true with respect to dioxin growth. The options are there is a second lag phase in the growth curve. There is a sequential utilization of substrate one after the other. The substrate on which the specific growth rate is higher is utilized after the substrate on which the specific growth rate is lower, and the substrates are utilized simultaneously. So, what do you think is the answer to this? B and C. Alright. A, B. Alright. Any other answer? B, C, D. Alright. B, D. Okay. So the answer to this is first, before I move on, I'll just show you what a dioxide growth curve looks like, right? So in this, the nutrients that are provided to the cells are two. So glucose and lactose are added, and the first curve that you see is that of glucose. And once the glucose is used up, you see a growth on lactose, right? So the answer to this question is that there is a second lag phase in the growth curve, which is the one that you see in the curve between the growth of glucose and growth on lactose. There's a lag phase, right? And there is a sequential utilization of substrates one after the other. So the cells don't utilize glucose and lactose together. They will utilize glucose first, and when glucose gets finished in the medium, then they will move on to lactose, right? So the correct answer in this case is A and B. Alright. Uh, the specific growth rate in this case is not exactly useful. Like it's not a reason why the cells are taking these nutrients at a different time, and the substrate are obviously not utilized simultaneously. So C and D are not the correct answer. So moving on to question number 3. If the substrate concentration S is much greater than Ks, then which of the following is true according to the Monod's model? So the options are: the organism grows at its maximum specific growth rate, the specific growth rate of the organism decreases, the specific growth rate of the organism doubles, and the organism reaches stationary phase. So what do you think the answer to this is? B or C? Alright. Any other answer? No other answer? Everyone else thinks it is A and C. A or C. Alright. So before I move on, what does it imply when you say that the substrate concentration is much higher than the Ks? In this, the double arrows that you see imply the much higher part, right? So if um, S is much higher, then we can neglect the Ks altogether, right? So this is the original formula, right? Where this is the formula that you've been given. But in case we have uh, S is much greater than Ks, we can just ignore the Ks, right? So what we get is mu m into S divided by S, because we've neglected to take the Ks, right? We won't take it because now it doesn't matter, right? Like Sir said, S is maybe 1000 and Ks is maybe 1. So there's not a lot of difference between 1000 and 1001 in this case, right? And because you have S in both the numerator and the denominator, they both get cancelled. So what you get is mu g is equal to mu m, right? So the correct answer would be just A. So the organism grows at its maximum specific growth rate, right? So that is the answer in this case. All right. I'm moving on. In case anyone has a doubt, please do write it in the chat. Okay. So question number 4 is, I hope you guys have a pencil and a paper nearby, because this you might have to solve. An industrially important enzyme is produced from thermophilic bacteria in a bioreactor operated in batch mode, right? 50 liters of media was inoculated using 8 grams of cells. The lag phase was found to be 60 minutes. Okay. The maximum specific growth rate of the organism is 0.36 per hour under the conditions maintained. Calculate the cell concentration after 6 hours of growth. Choose the answer closest to your calculated answer. So I hope you guys have a pencil and paper, because I would like you to solve it and see what is the answer that you're getting for this. We'll wait for maybe a minute or two. Does everyone know how you would solve this question? Please write no in case you don't. If you don't have a clue how you would go about solving this question. B, 100, 100. I will explain it to you, but just in case, just try. Just try with the formulas that were there in the presentations by Sir to see if you can figure out. So uh, think about the way Sir tells us to go about solving a problem. First, you have to make a list of what is there and what you have to find out, right? So just do that and let's see. I'll give you maybe 2 minutes and then I'll tell you how to solve it. Did anyone manage to solve this? Apart from one answer, I don't think I see any other answers as such. And does anyone have an idea of what the answer could be? Okay, I will move on to what is there. Okay, so on the left hand side is what is given to us. So the initial inoculum added is 8 grams, right? Like you would see here, 8 gram of cells were inoculated, right? And the volume of the reaction is 50 liters, right? Because 50 liters of media is used, right? And the initial concentration of cells is because they've given you as a lump, right? A lump sum, they would have given 8 grams and 50 liters, but that is not the concentration, right? So to get the concentration, you will have to divide 8 by 50. So you have 0.16 gram of cells per liter. Okay. The specific growth rate that is given to you is 0.36 per hour. The lag phase is 60 minutes in this case. The time that the since the question is calculate the cell concentration after 6 hours, the t in this case is 6 hours, and what you have to find is x, which is the concentration of the cells after 6 hours, right? So this is the formula that has been given to us, right? 1 by mu ln x by x naught plus t naught equals to t. So what you have to find is the x in this, right? So you know what everything else is. So you divide 1 by 0.36, which is the specific growth rate, ln of x by 0.16, which is the x naught, which is the concentration at time equals to T0. And since the 60 is given in 60 minutes, right? And the everything else is in the units of hour, so you have to convert the 60 minutes into hour, which will be 1 hour. So 60 by 60 you will get 1 hour equals to time equals to 6, right? Because you're calculating how many cells are there after 6 hours of growth, right? So once you solve this, you will get T equals to 0.967 grams per liter. Do you guys want to try and solve this once? Uh, were you able to understand how I have solved this? Do you have doubts in the way it is solved? So I'm hoping you guys were able to get this. So the answer would be, in this case, 0.967 grams per liter, right? So that is the amount, the concentration of cells in the reaction after 6 hours of growth, right? In the log phase itself. Okay. So at the same conditions as above, what is the time required to yield a cell concentration of 2.3 grams per liter? Okay. So just write it down somewhere, 2.3 grams per liter. Okay. And use this formula again, because again everything is there in this formula. It's just that you what you have to find is something different. Okay, so what you have to find is uh, the time required. This time what you have to find is the time required to yield a cell concentration of 2.3 grams per liter. Okay, so do you guys know how you would be able to find this? Oh wait, I think I made a mistake in this, right? Just one sec. I will stop sharing. It's not t in this case. It's x, right? So what you had to find was x equals to 0.967. So I made a mistake writing this. I'll correct this after the meeting is over. Okay. So this is not t here. What you're trying to find is x. So in this formula, now what you have to find is t in the new question. So do you guys know what the answer will be in this case? 2.3 grams per liter concentration, what time it would require with the same initial conditions that were given in the question. Have you managed to calculate it? Do you at least understand how you would, do this question? It's very similar to the last question. You just have to change a few things, right? The formula is the same, right? Okay. So how you would calculate it? Again, the initial inoculum added is 8 grams. The volume of the reaction is 50 liter. The X naught is again 0.16 grams per liter. The specific growth rate is 0.36 per hour. T0 is 60 and X in this case is 2.3 grams per liter. And what you have to find is T, right? So when you plug in these values, you find that T equals to 8.4 hours. So the correct answer is 8.4 hours. Does anyone have a doubt regarding this question? Is there anyone who didn't understand how to solve this question? Okay, I'm moving on, assuming that you have understood. So question number 6 is what happens if the dilution rate is larger than the critical dilution rate? Okay. So the options are washout occurs, there is better control of the growth rate, substrate concentration is equal to the inlet substrate concentration, and there will be conversion of substrate to the product. So what do you think the answer to this is? Please respond, guys. What do you think the answer to this is? D. Alright. D or B. Anyone else? Anyone else choose something other than D or B? Mhm. So the answer to this is what is the critical dilution rate, right? This is the graph that was there in the module that you've seen, right? So what you see is that the cell X is the concentration of cells, right? It goes down to zero at the critical dilution rate, right? and the substrate concentration becomes equal to the substrate concentration of the inlet, right? So the correct answer is if the dilution rate is larger than the critical dilution rate. That is, if the dilution rate has crossed the critical dilution rate, the DC here, then washout occurs, which means that there are no cells coming out of the outlet, right? And that the substrate concentration is equal to the inlet substrate concentration. That is what you can see here. So at the critical dilution rate and beyond it, the substrate concentration becomes equal to the substrate concentration of the inlet because no cells are present, right? And after the critical dilution rate, so that means no substrate is converted. So whatever substrate you were giving at the beginning from the inlet, it is going out from the outlet itself, right? So the correct answer in this case is A and C. Okay. Question number 7 is cell productivity in a chemostat is defined as, the options are amount of cells produced per unit volume per unit time, the amount of cells required per unit volume of product produced per unit time, the amount of substrate required per unit volume per unit time for cell growth, and the amount of substrate converted to product per unit time. So in this case, what do you think the answer is? A. Okay. A. Any other answer? Right. The answer is, in fact, productivity is defined as the amount produced per unit volume per unit time, and that is option A. So you guys are correct. The answer is amount of cells produced per unit volume per unit time. Alright. So moving on to question number 8. This is again a numerical sort of question. So Pseudomonas species is cultured in a chemostat for the production of lipases, which is an enzyme. The chemostat has a capacity of 100 meter cube. Substrate concentration in the continuous feed is 50 grams per liter. Ks for the organism is 0.69 gram per liter. Under the operating conditions, the organism has a maximum specific growth rate of 25 per day. So what you have to do is estimate the feed flow rate required to achieve 90% substrate conversion. Okay, so you have to choose the answer that is closest to your calculated answer. Okay, do you know how to solve this? Can you think of what the answer is? Can you try solving it? Again, there is a very straightforward calculation to this. There is a little bit trick, but apart from that, there is a formula given to you, which is all you require in this case too. So, in case you don't know how to solve this, just write no in the chat and understand. Does anyone know how to solve this? You can unmute yourself and tell in case you do know how to solve this. Alright, so no is what everyone is saying. So again, you will have to see what information is given to you, right? So you know the volume of the reaction is 100 meter cube. You know Ks is equal to 0.69 gram per liter. You know the maximum growth rate is 25 per day, but since everything is calculated in a hour basis, what you have to do is uh, divide 25 by 24. So what you get is 1.04 per hour. So that is the maximum growth rate. Si, that is the substrate concentration in the input value is 50 grams per liter, and what you have to achieve is the 90% conversion, right, of substrate. Okay, so what that means is, uh, because you know that the substrate concentration at the input is 50 grams per liter, so 90%, which is 90 by 100 or 0.90 of 50, will be 45 grams per liter. Okay, so what that means is you are converting 45 grams per liter of the substrate that is being given to you, which is 50 grams per liter. So the substrate that is going out of the outlet is 50 minus 45, which is 5 grams per liter, right? So that means input is 50 grams per liter, but since you're using 90% of it, all that is left and that is going out of the system is 5 grams per liter. All right. Now you have this formula where um and sm divided by ks plus sm equals to dm, right? So you have everything that you need here. What you're finding is the dilution rate, right? So dm is the dilution rate. Okay. So nu m is 1.04 per hour into sm, in this case is 5, divided by ks, which is 0.69, plus again 5, which will give you 0.913 per hour. That is the dilution rate. What you have to find is the feed flow rate required to achieve 90% substrate conversion, right? So you have the dilution rate, and you know that the feed flow rate is equal to volume into the dilution rate. So volume you know is 100 into the dilution rate that you have calculated is 91.3 meter cube per hour. So the correct answer would be 91.3 meter cube per hour. So was this clear? Did you understand how this is solved? How this question was solved? What was given in the question and what you had to calculate? All right. Is there anyone who didn't understand and wants me to repeat it? Okay. Is the yes, ma'am, for you have understood, or is it for you want me to repeat it? Just write repeat in case you want me to repeat it. Understood? Alright. So, since no one has written repeat in the chat, I'm assuming everyone has understood. So we'll move on to the next question. So a group of microbiologists isolated a bacteria from an industrial plant operating at high temperatures, which is more than 80 degrees Celsius. Okay. The temperature range, which is the T max minus T min, for growth was, however, narrow for the organism. Under which of the categories given below does the organism belong? Okay. The options are A. Mesophile, B. Thermophile, C. Stenothermal organism, D. Eurythermal organism. So, what do you think the answer is? Again, it could be multiple answers, right? Hmm. Okay. Look at the question sort of carefully. So, the organism, the bacteria that they have isolated is from a industrial plant which operates at a very high temperature, right? That is more than 80 degrees Celsius. Okay. And the temperature range, that is T max in this case, the maximum temperature at which they can grow, and the T min, which is the maximum minimum temperature at which they can grow, is narrow. So, what do you think the answer is? B and C. Okay. B. And so the answer in this case is B and C. So you were right. The answer is B and C. Since the bacteria is growing in a temperature which is more than 80 degrees Celsius, it is a thermophile and not a mesophile, which would grow in normal ambient temperatures. And since the temperature range for growth is narrow, it's a stenothermal organism and not a eurythermal organism. Eurythermal organisms have a very broad range of growth, right? Growth temperature. So the answer is B and C. So moving on to question number 10. Identify the device or devices used in aeration flow rate measurement in a bioreactor setup. It is a very straightforward question, so I mentioned it in the video. So the options are A baffles, B rotometer, C RTDs, and D mass flow meter. Right? RTDs in this case is resistant temperature detector. Right? So what do you think the answer is? B. All right. B. A and B. All right. B. So the correct answer actually in this case is B and D. Okay, both rotameters and mass flow meters are used to measure aeration flow rate. Baffles are something in a bioreactor that helps sort of uh, when there is a lot of agitation to sort of control that baffles are there, and RTDs are used for temperature measurements, right? So the correct answer is rotometers and mass flow meters. Okay. Now moving on to question number 11, and this is the last question for today. Which of the following is used to estimate KLA using dynamic response method? So to determine KLA, what will you measure? Oxidation of sulfides, dissolved oxygen, pH, or aeration rate? So what do you think is the correct answer? A. 100. Any other response? Uh, no other response. Let's see. I can't see anything. The answer is dissolved oxygen. So you use dissolved oxygen measurements to estimate the KLA using a dynamic response method, right? So that is the end of the questions for today. I hope these will be of help for you for your assignment number 3. Apart from that, the questions that I've taken today, if you have any doubts, please write it in the chat or unmute yourself and ask. If not, you can leave the meeting if you have no other doubts. Thank you for joining me today. We'll meet again next week for the final module, right? Thank you, everyone.
Ma'am, please share link for PPT, ma'am.
Uh, I think it was there, right? Is the link for PPT not being shared with you? I have given the link for PPT, but I guess we haven't shared it with you. I think this is the link for PPT. Can you just check in case you're able to open it or not? Are you able to open it? I've
I
given
need a big two, ma'am.
what? No, no. As in this Google Slides will have the PPTs for all 4 weeks. So if you go forward, you will get it for week 2, week 3, everything. Just check it. and the video that I have recorded for today's session will also be there on YouTube. Alright. So thank you for joining everyone.